Today we're going to continue talking about systems of equations, but now we're going to look to see what happens when we're given a lot more information with word problems. So we want to underline or circle key information and numbers. So blah blah blah. John had an electrical problem at his home. This part's not really that important. He called both Saul's electricians and Kevin's electricians. Okay, that's not really that important. Saul's electricians charge a flat fee. So flat fee we know is important. We have $90, and then it says plus, that's going to be important, $20 an hour. Kevin's electricians charge $45 an hour plus a flat fee of $40. So X represents the number of hours, Y is the total amount charged. And then we're going to have to pick an equation that goes with that information. So remember that a flat fee is something that you only pay one time, so we don't need a variable. Okay, so we know that 90 and 20 have to go together. And because this was $20 an hour, every hour, that needs an X. And they told me it was plus. All right, so then the other information that goes together is $45 an hour and a flat fee of 40. All right, so let's see which ones go together. So 90 and 20, no. Yes, but there's a minus sign, so no. 90 and 20, yes. Let's make sure 20 has the variable, good. And then 40 and 45, yes, and 45 should have the variable. So this is my correct answer. All right, so now we're going to actually have to write and solve. So it says 7 family members went to the movies. They spent a total of $61.50 for the movie tickets. Child, so that's going to be one of our variables. We're going to make that X, cost $6.50 each. And adult tickets, another variable, we're going to make that Y, cost $10.50 each. And we're looking for how many adult tickets were purchased. All right, so the two equations we need are the number of people and the amount. So the number of people we know is equal to 7, and we had some children and we had some amount of adults. We don't know how many of each. The money, we do know some information about. We know the total was $61.50, and child tickets cost $6.50 each, and we know that adult tickets costed $10.50 each. So now we have two equations we can solve. We're looking for how many adult tickets, so we're going to be solving for Y, all right? So let's go ahead. You can see that neither of these are ready to solve. So we're going to go ahead and solve one of these, this equation for either Y or X. I'm going to go ahead and solve for X so that Y is still in my answer. I'm sorry, I'm going to go ahead and solve for Y so that that's still in my answer. Because X is the variable I don't want. All right. So now I know what X is equal to. I can substitute that in for X. And this is if you wanted to solve it algebraically. I'm going to show you in a second how to solve it by graphing, which is what we learned last class. All right. So 650 times 7 gives me 45.5 minus 650 or 6.5y plus 1050y equals 6150. All right, so now I have a y and a y. I can put those together. And that gives me 4y. Now I just need to solve for y. And that gives me 16. Divide both sides by 4. So y equals 16 divided by 4, which is 4. Okay? So that means the number of adult tickets, so number of adult tickets was equal to 4. So that's my answer. Now, if we wanted to do it by graphing, you would need to solve each of these for y. Okay, So we would subtract x from both sides. Okay, this is now solved for y. Here, it's a little bit more complicated. Okay, you would need to subtract 650x from both sides. Okay, and then divide by 1050 or 10.5 on both sides. So this would leave you with negative 0.619x plus 5.857. And then you would graph this, use second trace 5, and then you would be looking for what y equals at that intersection point.